Today I wanted to talk to you about a very important HC, hashtag algorithms. We'll do it in 3 steps. The first step, I'll look at the definition that is provided of this HC. The second step, we'll look at a simple example of what an algorithm could be. And in the step 3, we'll look at the material that you learned during the formal analysis class. Namely, we'll look at De Morgan law as an example of hashtag algorithms. So let's jump into it. Algorithms apply algorithmic thinking strategies to solve problems and effectively implement working code. Okay, so let's break it down. Something that is important is algorithmic thinking. So things that you need to know is that algorithms are steps that you should follow, just like a cooking recipe. You should follow them in order to accomplish a particular goal. Your goal is either to have an implementation of something, to sort things, whatever. What matters are the steps and how do you design them. In class, you'll be working on implementing working code, so the steps in Python or different programming languages. So let's take a simple example of sorting algorithms. Here we have a list of numbers before sorting, and we have a particular sorting algorithm, which will be just the approach. Just like you can bake cupcakes in multiple ways, you can also sort a list in multiple ways. So our end product is here, it's the sorted list. And the algorithm would be quicksort. So if you're interested, you can definitely take a look at what quicksort is. It will be very useful in later CS classes, and you can take a look at the recipe. But the overall goal of this video is not to show step-by-step quicksort, but moreover to give you the overview of what algorithms are. So I broke it down here. This is our cooking recipe for the quicksort algorithm. So feel free to pause the video and look at our cooking pseudocode for the quicksort. The list that you saw on the previous slide will be sorted if you take those steps recursively. Recursively means that you just have to follow the red arrow and you have to just come back to the step and repeat it overly and overly in loops. But another thing that might be very important and relevant, take a look at this slide. This last slide in our video shows De Morgan's law. De Morgan's law you will learn probably in the context of formal logic, which is very important in formal analysis course. So basically what you'll be looking at is Venn diagrams where you have two sets, S and T, and you will find using an algorithm, so step-by-step recipe, you'll find equivalence that you can rewrite negative P and Q as negative negation of P or negation of Q. You can find using the truth tables, and once again feel free to pause the video and take a look through the truth table, and using the algorithmic thinking you'll arrive at equivalent statements. So basically that just means that the truth table outcomes are the same. So this is another application of algorithmic thinking. Good luck!